Today we will discuss about a very important question, reduction of two body problem to equivalent one body problem. In this we have two bodies having masses m1 and m2 which are at position vector r1 and r2 respectively with respect to any coordinate system. Now the distance between the two particles is represented by r, where we can see that in this triangle O, let us mark it as A and this as B. So in this triangle O, A and B, we will have OA plus AB, that is equal to vector OB, that is R1. So that means R2 vector plus vector R will be equal to vector R1. So we can say that the vector R, this will be equal to R1 minus R2. Now these two particles, they are under the force of attraction, gravitational force of attraction, which is a mutual force, and hence the force which the particle with mass m1 will apply on mass m2, and the force which the particle of mass m2 is applying on the particle with mass m1, and as a result of this force these two particles will be having acceleration. So m1, by according to directly Newton's law of motion, so we have m1 is to double derivative of r1 with respect to time, that is equal to force acting on the first particle, that is the particle with mass m1. Now similarly the force acting on the particle m2, that is equal to f2. So we have m2 is into d2r2 by dt square. So from here we can see that the double derivative of r1 with respect to time can be simply taken as f1 over m1, and double derivative of r2 with respect to time will be taken as f2 over m2. Now if we subtract these two quantities, these two equations, so we will have double derivative of r1 with respect to time minus double derivative of r2 with respect to time, that will come out to be f1 over m1 minus f2 over m2. Then now since these forces f1 and f2, they are equal and opposite, these forces being forces of attraction, gravitational forces of attraction between the two particles. So they are equal and opposite to each other. So we can simply write that F1 is equal to F2 with a negative sign because they are opposite to each other. So let it be equal to F. So we can replace F1 and F2 by F by M1, and plus in the second case F2 can be written as minus F. Then again this equation will be double derivative of r1 with respect to t square minus double derivative of r2 with respect to t square, that will be equal to f over m1 plus f over m2. Now if we take it as common, then we will simply find that double derivative of r1 minus r2, that is equal to f into 1 by m1 plus 1 by m2. But we had already seen in the diagram that r1 minus r2 was equal to r. So since it was, and where r is the distance between the two particles m1 and having masses m1 and m2. So double derivative of r with respect to t square, this comes out to be f into 1 by m1 plus 1 by m2. So here we will replace, we can say that the quantity 1 by m1 plus 1 by m2, this is equal to 1 by mu, where mu stands for reduced mass. So we can have double derivative of r equal to f over mu, or f is equal to mu into double derivative of r with respect to time. So the concept is that we have replaced the mass or system of two particles having masses m1 and m2 by a single mass, that is called the reduced mass mu, and we can treat the system as if we have a single mass at a distance r, where r is basically the separation between the two particles. So we can, in this, simply we have already reduced this two body problem to a one body problem. So we have this relation. Now if, since in this case the forces between the two particles were only the gravitational forces of attraction, so F is basically equal to minus G, that is the gravitational constant, m1 into m2 over r square, and ER means the unit vector along the line joining the two particles. So this force being a central force, so in this equation mu into d2r by dt square is equal to minus gm1 m2 over r square into ER. So this is the equation of a two body problem when it is reduced to one body problem under the action of any central force. Now we can see as a special case that if the two particles having masses m1 and m2, then the reduced mass we have already defined it as 1 over mu is equal to 1 over m1 plus 1 over m2, or mu is equal to m1 into m2 over m1 plus m2. So dividing the numerator and denominator with m1, we can simply see that we have m2 over 1 plus m2 over m1. Now let us suppose that the mass of m2, the mass m2 is very small as compared to mass m1. So this fraction m2 over m1 will be very small as compared to 1. So we can simply apply binomial expansion on this. Hence mu will be equal to m2 into 1 minus m2 by m1. So in case of, if we apply this to the hydrogen system, atom, so the mass of the electron to the mass of the proton, mass m2 being the lighter particle and mass of proton being the heavier particle, this is of the ratio of 1 by 11836. So substituting this, we will find that mu will be very close to the mass of the electron. So in general, we can say if we have a two-body system in which one particle is very light as compared to the other particle, then the reduced mass will be close to the mass of the lighter particle. And similarly, we can apply it to the case when the two particles have equal masses. Then we can have that if two particles are equal, then the reduced mass is equal to half of the two particles.